we are good to start with the NoSQL database and the HBase. And in the NoSQL database, what is going to be our focus is basically the HBase. And so when we'll see the landscape of the NoSQL database, it has multiple database which qualify itself as a NoSQL database. And when we talk about the NoSQL, it has several definition of the NoSQL. Like some people call it like not only SQL, or some call it just NoSQL. There is like no select star kind of a stuff, right? But only thing, right, whenever you are talking the NoSQL database, all the database has its own differentiator in terms of what kind of the functionality they offer. Only thing common what you will find in all these NoSQL database, that they don't have the SQL interface. So that's the only thing common. Apart from that, you have the multiple NoSQL database, and they all have their own way to access the data, put the data in that, delete the data, and all those stuff. So we'll understand about this, like how we interact with the NoSQL database and how we work with that. Okay, so when we talk about today's world, right? When we talk about the today's world, especially where you have the huge volume of the data, and basically the data is not something which fits exactly in like very normalized kind of the data or the structured data. What used to have in last 20-25 years, where majority of the the data which used to come to us, it used to be in the form of the structured database, and we used to normalize all those data, and then we used to store inside our data warehouse. But when the companies like the Google, Facebook, Twitter, they try to scale with all these the web kind of the presence they had, and the kind of the data they were getting, and the main thing in terms of the speed what they were looking for. So to get all the data set which they had, and combine that data set and then present on their site, or the whatever the interface they had, basically the web interface, they faced a lot of challenge in terms of the way we used to store the data. Okay, so that's like the one of the challenge they had, right? So when you talk about any kind of a RDBMS system or the database kind of the system, you have basically like when you go for a RDBMS kind of the setup, what you do is first you get a kind of a cluster machine, you install some kind of the RDBMS software on that, whether it's like MySQL, or you get it from some particular vendor. And then you start using your database, you connect it to your web interface, or whatever way you start inserting the data in your database. And then slowly what happens as your the size of your database starts growing, you start getting the problem in terms of the performance. Your the latency start increasing, and at that point, right, what you try to do is you try to put some kind of a caching layer in front of your database, so that you can access it in a faster way. But the caching has its own limitation in terms of how much you can put. And then what you do is you try to basically like try to relax some of the RDBMS the constant what we have, like you try to drop index and try to have like denormalize kind of the tables to avoid certain joins, and those things little bit give you like improvement in terms of the performance or the data what you look from your RDBMS kind of storage. And then also, like if your database performance doesn't increase, then in that case what you do is you start having like pre-computed materialized view, like where you can just write some SQL and you can get the data. Right. So once you travel this particular journey, like starting from setting up a RDBMS kind of the system, adding a caching layer, dropping index, putting denormalized table, having a materialized view, you basically move away from the benefits which RDBMS offers in terms of differential integrity or the indexing or ACID kind of transaction, right? So when a company like Google started basically storing their data, and the data which Google had is basically the data which was coming from the internet. One of the challenge they had is like the way they wanted to use the data cannot be stored in the way how the RDBMS were designed, or the way they were storing the data. So at that point, what happened? Google did a step back kind of the approach, and the approach was like to design something which will be able to meet the need in both the terms. One is like the scalability, because the volume of the data, as well as in terms of the performance, because the data need to be accessed in a particular way where you don't want to have basically the normalized kind of the data. You are okay to have the denormalized data as long as it gives you the performance. So that's where all this whole stuff is started, and Google implemented this whole concept in something called the Bigtable. So like how the whole journey of the Hadoop is started from the Google, where Google published the MapReduce paper, Google file system. So on the same line, Google had the third paper, that's basically the Google Bigtable paper. And that paper, people at the open source community, they took that and they implemented the whole stuff as part of this Apache open source umbrella. And that particular stuff is called something called HBase. That we are going to focus. Right. So when we talk about HBase or or the NoSQL database, so as we see here, like the example of the Twitter, right? So okay, I have a comment here. Let me take that. From Pradeep, right? So Pradeep says, okay, Angela Jolie is not a problem. Okay, okay. So yeah. So the thing what we are trying to bring it here is like, if you talk about the Twitter, if you talk about LinkedIn, Facebook, right? All these has the huge volume of the data that need to be basically stored and processed, and it cannot be stored on a single machine or in one particular database. And the data what you store is basically have the changes kind of the schema and as well as the kind of the structure what you store, right? So all those have like similar kind of the challenge which you are dealing with. So, to store all these kind of data which you are getting, right, you need a system which will be able to meet a certain kind of requirement or a certain kind of the characteristic, and based on that, you will be able to basically come up with a solution. So that's where you will see all these companies, most of them are nowadays using this NoSQL database that's able to meet their requirement in terms of the storage, as well as getting the data and coming up with the services based on the way they store the data. Right. So all these examples which we saw here are like be it Twitter, LinkedIn, Facebook, right? So all these have like few things common. They are dealing with a huge set of the data. And although the data is huge, the access pattern what we have is basically they need to quickly access in any kind of the data. Like suppose if you have, if you are talking about the Facebook and you posted some comments maybe last year, or you uploaded some picture a year back, if you want to access that, you should be able to retrieve that data set, right? So your data access pattern is very random. You are not just interested in the recent kind of the data, but you want to go back and access any kind of the data set. Then the data what you have is not only the structured data, but you have the structure, semi-structure, unstructured. So basically the combination of the data which you want to store. Like example of the Facebook, right? When you want to store Facebook, it has the image data, it has the text data, it has semi-structure kind of the data where people embed things, right? So all those kind of the data you want to store in your database, and you want to retrieve that. And one of the thing that is like common across all these the applications which you do, like if you talk about Facebook, Twitter, right? So all these applications, they keep growing, right? So every year you have some new kind of the features, new kind of the interface which is coming to that, right? So whenever you design a backend system for that, you don't have the upfront schema for that particular solution. Like take the example of the Facebook, right? Like suppose if you design the Facebook login page, like what the information Facebook might be capturing 2 years back in terms of the login phase. Today they capture altogether different set of information. Now, if you are migrating, like suppose earlier you were capturing like 10 columns, like name, maybe the primary email, the country and all. Now you, along with that, since you are offering multiple service, you ask user like provide the LinkedIn ID or maybe your Twitter handle, or some other stuff, right, which you are capturing all this. So you're basically the front end schema change, and you want your backend should be in such a way that if you add 10 more columns in your in your application, your backend should be able to accommodate all those 10 new columns without having too much kind of the overhead in terms of like how to accommodate that. If you guys have worked on an RDBMS world, you must see, right, suppose if you have in a table and where you have 10 columns, and if you add 5 more columns, you have a huge process. You have to work with your DBA team, get the new table created, then you migrate your existing data to the new table, and then you start using the new table to your application. So it takes a good amount of time to basically get to that particular state. With like HBase and other NoSQL database, what you will see that like one of the things we'll see that when you create a table, you don't even specify what is the column name and the data type, right? So basically you don't specify any structure, just you tell that, okay, this is my table name, and there's a concept called column family. So you just specify table and the column family name, and you create the table. When you start using that particular table, at that particular point you specify, okay, this is my column and this is my value. Go ahead and insert that. And HBase has those kind of the flexibility where it will be able to take that request, it will create that column, and it will insert that, right? So that's the kind of the support it has for the schema. So it can support all these variable schema kind of requirement. Okay. So apart from that, what else it has is like the compression, because you are dealing with the huge volume of the data. It has its own compression, the way the files are stored, and you retrieve the data set. So the compression is also inbuilt in all these kind of the requirement which you are dealing with. Okay, and the last thing what we have is since you are dealing with the huge data or the big data kind of the problem. All this data cannot be stored in one particular machine or a single machine. So you have to basically distribute this data across multiple machines. With all this, the NoSQL architecture or the HBase kind of the architecture, what you will see that is it is having the way the architecture has been, it follows this master and the slave architecture, and you will have automatically your data will be distributed across multiple machines, so that whenever you want to scale it, you have the flexibility, you add more machine, and you can store more data, and you can get the better performance, right? So to meet all these needs, we have all these NoSQL requirement that basically able to provide you solution to some of the problems which are listed here. Apart from that, if you guys able to recall our Hive discussion which we had last week, we just saw that Hive is basically a interface where which is on top of the Hadoop, and by using that Hive interface, what you can do is you can have you can create table, you can insert the data, you can retrieve the data, right? But one of the thing which Hive doesn't offer, and that's very, very common across all this NoSQL world, is basically the ability to perform kind of the update or delete for the data which is stored inside the table, right? So like in case of Hive, you have created a table, and if you want to do some selective delete, like a row which is not needed there, you cannot do that in Hive, because in Hadoop you can only append the file, you cannot go and modify a particular file, right? So that's also like when the people across multiple industry, they starting this Hadoop kind of solution. One of the demand or one of the features they were looking for is to have the support for all these kind of something we call is CRUD operation. So basically the create, read, update, and delete, right? So they wanted to have this kind of the flexibility, because whatever the RDBMS world we had seen earlier, they had basically these functionality where you can selectively tell that, okay, this is the the key, and based on the key you wanted to have the update or delete. So in case of HBase, what you will see that it supports all these operations. So by using HBase, now you can go ahead and update a particular record, you can go ahead and delete a particular record, right? You can go ahead and fetch a particular record, right? So those kind of the stuff is now supported with the help of the HBase implementation on top of Hadoop. Okay. right? So like suppose if you want to build a an application like LinkedIn kind of application where you have the huge data set, you want to relate all these data, like if you have multiple users who are coming and signing on the LinkedIn, and based on their kind of the information which they provide, the company they work for, the project they work for, right? So based on that, you want to have a kind of a connect of them, right? You want to suggest the people you may know, or may working on the similar kind of project, or or the kind of company. You need to basically analyze the whole data set which you have. So the data set is the huge, right? And then you want to bring the data set together so that you know that, okay, if the two people have the working for the same company, the chances of they may know each other is very high, right? So you basically want to solve all this stuff, right? So now if you go with the normal RDBMS approach, what you can do is you can have one table where you will have the users detail, one table where you will have the the different connection detail, and whenever you want to bring the data set together to your site, you have to basically connect these two tables, and then you get the data, right? In case of the HBase kind of the table, what you will see that you can have all those data is stored, like a particular user and what all connection that particular user have, all those can be stored together as a single row, and with a single API fetch you can insert the data, update the data, and get the data, right? So those kind of stuff now are possible to do in altogether different way than we have been doing with the help of the relational database kind of the system. Right. So the kind of the challenge or the problem which we saw, the solution for that is one of the thing is it's a huge volume of the data. So it's basically you need a distributed database kind of thing where you can store this data, and then you can perform all these update, delete, and insert kind of the operation on this huge volume of the data that is distributed across multiple machines. Okay. Right. So one of the things is this huge volume of the data you are dealing with. So the data is distributed across the multiple machine, and you need this to happen automatically. So you don't want to basically take the overhead in terms of distributing the data and then retrieving the data. So all these things need to be taken care by the system itself, right? Then the second stuff, what you have is the need for having data to be sorted. If we talk about the HBase, or if you talk about the Google, right, where it has, let me get an example of this one. One of the thing, right, whenever you are trying to understand about any of, as I told, right, when we're talking about the Hive and the Pig, right, so whenever you try to understand any of these Hadoop tool, you have to understand, or Hadoop tools characteristic, you have to understand, like what is the user's pattern, or what's the background it has in terms of having this particular feature. So like if you are talking about all these data, like when you talk about the HBase, the data in HBase will be automatically sorted. Now the reason why this data need to be sorted, you can understand with like the simple example, like what the Google need is, like so like if you talk about the Google, right? So Google has whole the internet data which we get in the Google. So like Google has like there is a company called abc.com, right? So Google has all the details related to the abc.com inside their database. So abc.com can multiple the pages, like it can have abc.com, then it can have like something called mail.abc.com, then it can have something I'm just taking like ftp.abc.com, and then you can have some other company as well, like www.abc.com. Now when it comes to the Google, right, it may happen like you have something called like this, right? Your data the Google may have the data something like this way, right? Now when it comes to the, like somebody, if they're looking to, like for this company like abc.com, like suppose if you work for that and you just want to access the email, in the Google just you are going to do something ABC, right? You're going to search for that. Now, Google need to have a mechanism to identify from this huge volume, like you have, millions of the pages which you have hosted on the internet. From there, it has to fetch out all the pages that relate to the ABC. Now, when you try to do that, one way, it can display like this way, where the first page is abc.com, then second EBC, and then EBD kind of thing. Now, instead of that, what Google does is, Google, whenever you store, or Google, whenever you store anything, they basically store all this kind of information in a very sorted way. So, basically, when we talk about the Google, it will store these pages something like this, abc.ww, and these are based on the pattern, like how the people uses these database. abc.mail, then it will be something like com.abc.ftp. That is not just basically paying attention in sorted. All I want to bring you here is like why we need the data to be sorted. So now if you have store your data in this particular way, where you have the sorted the data, like so maybe this will come first, right? I think this will come last. Right. So now if somebody comes and search for ABC, Google can link all these pages together. So it has to okay, com.abc, and this find this all these pages, and based on that it can list all the first 10 pages that will belong to abc.com. So so this is like one of the requirements. Similarly, if you talk about the Facebook or the LinkedIn, so there also the user details will be sorted internally, so that you can find all the related stuff together. So by default, you will see all these HBase kind of storage. They have the data that will be sorted. This is like one of the example based on like the real the use case. You will find a lot of the requirement where you want all these data set to be stored together. Then the second stuff, what you have with all these databases, basically the sparse data store. So what the sparse data store is like, if you design a Facebook kind of the application where you put like 100 columns or 100, like if you are getting the information about the profile creation, you have all the set of all a set of questions which you want to ask from the people, but hardly anybody provides all those information. So some may provide you the the location they are or the profession they are working for, but most of them, they may not provide that. But if you design a normal RDBMS kind of solution, what will happen? You have to have basically provision, like where you define each column structure, and you tell that, okay, even though we are going to get the data or not, for each row I'm going to allocate like 10 characters or 20 bytes for basically storing this particular column data. So if you have a lot of null values that you want to store, like one of the column is null, you need to have a mechanism to basically store that in the normal RDBMS world. In case of the HBase, it uses something called the sparse matrix. So with the help of the sparse matrix, what you can do is, if you have any value is null, you don't need to basically store anything about that particular column or that particular cell. Whenever you are retrieving the data, the null values will get automatically calculated based on the storage pattern which they follow. So basically all the overhead related to how to handle the nulls in terms of the storage is basically handled very well in terms of the storage sparse storage which it follows. And then you have this automatic sharding. So basically your data get distributed across multiple machines in a very automatic fashion, so that solves the problem with the horizontal scalability. So as you grow, you add more machines, and basically you will be able to do more read and write operation. Right. So all these basically lead to kind of a solution, and that basically gives a kind of opportunity to have come up with a multiple kind of the implementation that will be able to meet these challenges in terms of the distributed database, sorting the data, handling the null values, and having the automatic sharding in terms of horizontal scalability, and by adding the more machines. So when it comes to the solution, you don't have just HBase as like one of the only the database which offers this. But it's basically gives you the landscape of this particular slide. What it gives you is like the complete landscape of the NoSQL database. So you have the multiple database that qualify itself as the NoSQL database. Like you have DynamoDB, you have the Bigtable, Cassandra, MongoDB, you have all these FlockDB, Neo4j, right? So all these databases qualify themselves as the NoSQL database. And only thing you will find common across all these databases, like they don't have the SQL interface. Right. So apart from that, what you have is like all these NoSQL database, although all of them are having a similar kind of the problem which they try to solve with the huge volume of the data, and the different kind of the data they store. But based on their characteristic, they are basically categorized in all these 4 categories which you see on your screen. So one is called key value store. You're going to understand what's there. Then you have the Bigtable clone. So basically the kind of the database design which are influenced by the Google Bigtable paper. So all those kind of things it calls Bigtable clones. Then you have the document database. Like if you have your data in like JSON format, XML format, and if you want to store that and analyze that, so those are like in the document database you have. Then if you have the requirement of having the graph database where you want to link the different kind of the data elements which you have, and you want to analyze in the node and edges kind of the format, so those comes in the graph database. So all these the implementation, they differ in terms of or how they are implemented, or on what kind of the problem they try to solve. Like if you talk about the key value store, where you store the data based on the key, and you fetch the database, all the value of the of a particular record based on that particular key, right? So they are called basically the key value store. Something similar what we have in the HBase as well. So in the key value store, you have something like DynamoDB. So that's a kind of the offering from Amazon. So it's a kind of Amazon cloud offering, and they offer it as kind of a database as a service. So it's a kind of a simple, cost-effective kind of the way to store the data and retrieve the large amount of the data on the clouds, right? So that's like their primary database which they offer as the NoSQL database on the cloud. Similar way, you have Voldemort. That's again used by the LinkedIn, and it's again a key value store you have. And if you guys are kind of the Harry Potter fan, right? So you must be able to relate it with the the famous villain in that, right? So that's kind of the name it has, and it's used at the LinkedIn. Then you have all these like React and the Tokyo cabinet. So they are basically again influenced somewhere by the Amazon Dynamo paper. Like React is basically implemented on the same principle of the Amazon Dynamo paper. And you have a lot of good use case for using this one, like Best Buy and AOL. They use that, and basically it's for their fault tolerance and kind of the support they provide. And the interesting thing is DynamoDB is basically from Amazon, but this React and all, it's free, right? So you can just go ahead and use that to meet a similar kind of requirement. Tokyo cabinet, again, it's a kind of the key value store, and you have like delete, retrieve, all these things you can do based on the key value stuff. And only thing is, this whole stuff is implemented in C++, so you have different kind of the performance benefit with using that. So that's all like the key value store kind of implementation of the HBase database, and that's basically comes the influence mainly from this Amazon DynamoDB. Then the second category which you have is a Bigtable clone. So that's again from the Bigtable, or the the Google Bigtable paper which we had. So it's again has the concept of this row key, and the based on the row key you fetch and insert the data. So all these Google applications which you see like YouTube, Gmail, Blogger, right, .com, right, all those things are powered by having this the Bigtable kind of implementation. So similar to Bigtable and the key value store, what you have, so basically the combination of these two things is something called the Cassandra, right? So it was developed, the Cassandra was developed at the Facebook, and one of the author, right, who basically developed this particular stuff, he was also part of the Amazon DynamoDB project. So basically you will find The Cassandra is a combination of both the Amazon DynamoDB and the Bigtable concept, HBase concept. Right. So that's there, right? So then you have the HBase and Hypertable, right? So these are again the HBase is like what we are going to focus today. So it's based on again the Google Bigtable paper, and there are like multiple the definition for the HBase. It's called as the Hadoop database. Some people call it key value store. Some people call it column family oriented database, right? Some people call it like database with having version kind of different versions you can store the for a particular value, right? So all those kind of features it has. Similarly, you have this document database. So document database is again like where if you are dealing with a lot of JSON and XML file, and if you are not having a very flexible, or you don't want to adhere to a schema, you can basically go for this less rigid kind of the database. So like MongoDB is like one of the again popular. So it's implemented completely in C++, and it's used by the eWay, and it's very well supported for all these the document database which we have. Then you have the graph database, so where you want to basically analyze your data in terms of the node and edges kind of thing. You can use that. So one of the example is the FlockDB. That's again from the Twitter. So it's basically gives you the opportunity to analyze your data by linking the data together, and then seeing the the pattern common across between the different node and the edges. So as you can see here, the NoSQL database, it has a huge landscape which you can see, and you have the multiple kind of the offering of the NoSQL database. And I'm not sure which kind of thing your project or your requirement is, but like nowadays you have the multiple use case where people go for HBase, Cassandra, MongoDB, right? The Amazon DynamoDB. So there are the implementation for all these kind of database we have. But right as part of this particular class, what we are going to basically focus mainly on the HBase, how to deal with the HBase. That's what we are going to learn. Okay. So as I told, right, so HBase has multiple definitions. So it's something called a Hadoop Distributed Database. It is basically offer you consistency, sorted data which it is stored, it is sparse, that it handles the null and across the multiple machine, right? Okay. So now let's get started with HBase, because something which we want to focus as part of this class, and in terms of our understanding about the NoSQL database will be the HBase. So as I told, right, HBase is called the Hadoop database, and some people call it as a key value database as well. So basically, whatever way you understand, fundamentally it's a kind of the platform for storing and the retrieving the data. And when it comes to storing and retrieving the data, one of the key things which you have different than other stuff what we learned Hive and all, is basically it provides you the flexibility of the accessing the data randomly. Means you can write the data based on particular key, update the data, delete the data. So that kind of the flexibility it offers you. And in terms of the the growth of the HBase, as you can see, so the whole journey of the HBase is started somewhere in 2006. That's with the Google Bigtable paper, and then in 2007 it becomes a Hadoop project and the sub project. So like that way, and you have nowadays multiple release of the HBase. So you see here 0.92 release in 2011. Nowadays you have 0.96 and 98 kind of the release. So it's a very recent kind of the technology which you have, and you guys are learning. Although we are talking about the HBase, there are a lot of the bug fix, a lot of improvement in terms of the challenges which we have in HBase is going on, guys. And what you will find is it's very interesting to learn about all this stuff, because if you talk about few years back, nobody was talking about all this NoSQL database. Everybody was very comfortable with using SQL kind of an interface, but last 3-4 years, right? The people to meet the need in terms of the volume and the speed, everybody is moving from SQL to the NoSQL database, and that's where you will see that HBase like being one of the offering there, since it's free and it basically works on the similar kind of underlying architecture. That's basically the Hadoop architecture. So we'll see about the HBase architecture as well, how it stores the data and all. Right. So when you talk about the HBase and the normal RDBMS, so there are certain difference which we need to understand. So when you talk about RDBMS, it stores the data row-oriented form. So what it means that each row will be stored. All the columns for a row will be stored together. When you talk about the HBase, it's basically the column oriented. So all the value for a particular column will be stored together. In case of the RDBMS, what you have is you have a flexible fixed schema. So whenever you want to create a table, you first define the schema, like how many columns you want, and based on that, you go ahead and design your solution. In case of HBase, what you will see the flexible schema. So you can add the columns on the fly. What it means is, like, whenever you're inserting the data at that particular time, you will tell, okay, this is my column name and this is my value. Go ahead and add that, and HBase will be able to do that. If you talk about this thing in the normal SQL world, it cannot happen. But in terms of the NoSQL, the HBase, this is something which is possible. Right. So again, since HBase, I told it handles the null value, the storage. It uses the sparse matrix, so it's able to handle all these the fields which are null very gracefully. You don't need to basically have any kind of the overhead in terms of the storing and retrieving all those columns which are null. But in case of the RDBMS, it is not optimized for that. So you see some kind of the performance hit when it comes, like the column has a lot of null values. Right. So that's again HBase, you can handle that. And when it comes to the RDBMS, they are basically designed with having support the join, right? So all this research or all this innovation you see in the RDBMS, like how fast a join can happen in the RDBMS, that's basically the key USP you have for the that particular database. In case of HBase, you will see that it's not designed for the join, so you don't have the join. It offers you, in fact, instead of the join, it offers you to store the data in denormalized way. So you store all the columns which you need together, and you can retrieve that. So it's not something where you need a lot of the join. You can go with HBase. But in case if you need join, as we saw in the MapReduce, advanced MapReduce class, you can do the joins, because since underlying architecture is Hadoop, so you can still do the joins with the help of the MapReduce, but not very flexible or easier compared to what you have in RDBMS. So in case of the HBase, it has very tight integration with the MapReduce. So you can, since it's offering on top of Hadoop, so you can always use all this MapReduce concept on top of this storage. But in case of RDBMS, you don't have any such concept like the MapReduce way of processing. In case of the HBase, you have this horizontal scalability. So whenever you want to grow the size of the data or the processing, right, you can add more machine, and your whole whole infrastructure can scale based on the number of the machine which you had. In case of the RDBMS, it's very hard to basically scale, because if you want to scale up your database, you have to work with the vendor, get more machine, and basically wait for the next release, and based on that you go for that. So kind of the usage pattern between RDBMS and HBase. If you have your structured data, RDBMS may be a good kind of the solution for that. But if you are dealing with a lot of semi-structured data, unstructured data, or other structured data, right? So all different kind of the data set you are dealing with. So in that case, HBase may be a good example to basically go for. Right. So when to use HBase? So one of the thing is, like, when you are dealing with all kind of the data structure and structured data, you can go with HBase. When you have the high volume of the data that to be stored, so again HBase may be like one of the solution, because it has this horizontal scalability. If you want to have the column-oriented data, right, where you want to retrieve all the columns together, right? So like suppose if you want to find how many people are from a particular geo or particular country, right? So where you want to analyze the data based on the column, you can do that. Another thing what you have is the version data, right? So when you want to store the multiple version of the data together, you can store that easily with the HBase. If you go with the normal RDBMS, like suppose if take the example of like your password, right? Suppose if you want to store like your current password as well as last 2 old password as well, maybe for the security reason or whatever purpose kind of thing. If you go with a normal RDBMS table, at one point you can store only one value in a particular column. In case of the HBase, what you will see that each column you can store basically 3 versions of the data. So current, prior to that, and prior to that, right? So all these 3 versions of the data you can store and you can retrieve for a particular column or the cell. And even you can increase that more than 3 also if you want, you can do that. So it can store multiple versions of the data in the same row. High scalability because it basically grows as you add more machines. It can store the more data, so it is scalability also good, right? And all this data set, everything is underlying architecture is Hadoop. So if you want to integrate it with your existing MapReduce flow, you can easily do with the help of this HBase and the MapReduce integration. Right. So these are the the common use case where you should be looking for HBase kind of the solution. Okay. So when not to use HBase, right? So although we are talking about the HBase, so at like certain scenario, right? HBase is basically a kind of a solution which provides you this horizontal scalability and kind of the storage of the huge volume of the data. But if you are dealing with just a small data set or few thousand or million of the rows, going with a HBase may not be a kind of optimal solution because the overhead in terms of maintaining the cluster, storing itself may be too much, right? And another stuff is like if you are looking for a SQL kind of interface, like if you are looking at database, you create a table. In HBase also you create a table. But if you want to access your data with a SQL kind of the capability as we had in Hive and other stuff, right, where you want to write select star and do that, in HBase you cannot do that because HBase doesn't have the SQL interface. Nowadays, there are some, the projects which are trying to provide that interface, guys. But then again, it has the limited kind of the capability as well as the latency involved in that. And when you have the, like very small kind of the cluster, like less than 5 node or a small like 3-4 node cluster, and where the replication factor is 3. So in those cases, again, your data will be stored on the same machine, so you will not be able to get the performance. So if you are dealing, so overall, if you are dealing with a small volume of the data, a small cluster, and if you are looking for a a SQL kind of interface, then HBase is not a solution. Like in terms of the capability, HBase you can run on a single laptop as well, as you will see, right? On virtual machine you can run that, but then it's just for the development purpose, not something as a machine you can use that. Okay. So there are, the multiple use cases like Facebook uses this for their messaging system. So it's a kind of able to handle this. Right. So HBase, it is a scalable, robust kind of a solution, distributed, column-oriented, real-time supports, right? So it needs the real-time need, right? Key value kind of thing, you can store and retrieve the data based on the key. Open source project, and basically it has a linear kind of growth. You add more machine and your performance increases. So not only the Facebook one of the users, so you name any big kind of especially all this web company or any huge volume of data, they are using all these implementation which can handle the data, like Twitter, Facebook, Yahoo, Trend Micro, right? So all those have this the HBase kind of solution, and they are able to use this HBase to meet their real-time data storage and the analytics. Like suppose if you have a site where as soon as the user is seeing a particular page, you want to basically analyze that and feed certain content. So all those kind of the solution you can build with the help of the HBase. Okay. Okay. So before I go and more about the HBase, guys, are you guys able to get the understanding about the HBase? What kind of the database it has? So what the key feature of the HBase we have? So now Okay, so now there is two approach, guys. We can take it, right? So basically, one way is to since we are talking about the HBase, right? So one is like we have a couple of slides which will basically show you the schema or how the HBase is stored. Uh, that's the one way to basically take that. Other way, what I find generally effective is if you start seeing the HBase, how it looks like, how we create the table, and then you come back to the slides, then it makes more sense to understand basically what is the row key, what is the column family, what is the column family, what is the column name and the value, right? Okay, demo first. Okay, so let me get the HBase machine here. Okay, so give me a second. Okay, let this machine come up. So when we talk about HBase, guys, basically you have two way to interact with HBase, right? So one way is through the command line, like as we have been seeing, right? Pig, Hive, all these has the command line interface. So HBase also has the command line that's called HBase shell. So by using this HBase shell, you can create the table, you can update the data, delete all those stuff. You can do that. The other way, and that's the generally the common way how the people actually interact with the HBase, it's basically through the Java program. HBase has all this Java interface. So by using the Java interface, because generally you will use it for all this, the real-time application, where from the application you will insert the data, delete the data, and those stuff. So those kind of interaction which you have with the Java program. So I'm going to show you both the way. First, we will understand about the command line interface, how to interact with the HBase, how to create table, how to see the data, and all those stuff. Then all those operations which we are going to perform here, similar kind of the things we will do with the Java program. Okay, so let me get some water here. Okay, so let me tell you how to basically start this HBase. So first thing what you do is you do something called, so this I'm doing, guys, because last time the machine didn't work correctly. Okay, so few things I wanted to share with you guys. So whenever you will deal with or you will try to do the HBase on the virtual machine, guys, sometime this virtual machine, because of all this queue for configuration and all, it may not work correctly, right? So the first thing what you do is you do this sudo GPS and you see whether this hmaster is running or not. If it is not running, then in that case you may not be able to basically use the HBase on this virtual machine. Okay, so the couple of things you can do, right? So as you saw, right, you can go ahead and you can restart. So you can shut down the guest and you can restart that. Most of the time it will fix the problem, right? Okay, so once you are good with this one, right, so once you are able to basically get into the machine, and if you want to start with the HBase, what you have to do is something you have to do called HBase shell. What's the command you will use to start HBase shell, and then it will, if everything is fine, it will give you the command prompt where you can start interacting with the. Okay, right. So now here, before I tell you something, let me just test it whether my machine is working correctly or not. Okay, before I demo you something. Okay, cool. Okay, so once you are on the shell, right, HBase shell, what you do is first you do a command, simple list command. So list is just to see the tables. If you are able to run this particular command gracefully, right, you don't get any error and you get the some output from that, it means the HBase is running correctly on this virtual machine. Okay, this is the primary check. Why I want to tell you guys, because most of the time the machine is not in correct state, and if you just try to execute this command, you may not get the output. So that's what I want to stress, that first check that the machine is working correctly. Okay, Once that's the stuff done right, the infrastructure stuff is in place. Let's now understand like what all we want to do with the HBase, or generally what we do with the kind of the database or the storage stuff. Okay, so let's list like what all the general operation when we do with a table, right? So like suppose if you have to store the data, guys, what all the basic functionality you need in terms of the interface, or what all you want to know about the HBase to get it started. First thing, you want to create a table, right? Everybody wants to create the table, want to know how to create a table in HBase or not? Yes? Okay. So we'll learn how to create a table in HBase. Okay. Since we are seeing the NoSQL guys first time, so what I will try to do is, and always like you try to relate it with your existing knowledge of the SQL, like because in the SQL you know how to create the table, how to insert the data, how to update the data, how to delete the data, how to do a select star, right? So if you are able to relate those kind of activity with the NoSQL, you will be slowly able to get inside this, right? So first thing, how to insert the data. Next thing, what you have to do is, once you create a table, first thing is create table, right? Once you create the table, what is the next requirement you will have? Not store the data, right? So next thing we will learn is how to store the data inside the table, okay? Once you know how to store the data, what you will need the next, you would like to basically get the data, like whatever you stored, whether it's there in the table or not, okay? What else you would like to try after this one? Oh, okay, I already have this. Okay, modify, retrieve, update. Okay, selective delete, awesome, delete. Okay, so let me list all those stuff, guys. Okay, so we created the table, we stored the data, we get the value. So get the values basically retrieve. Okay, so then we want to do update. Okay, that's what the people want to modify or update or modify. Okay, then it was like the delete, right? So you guys want to delete the data as well. What else you guys want? Modify. Okay, same thing, selective delete data. Okay, so these are the basic stuff we would like to perform in a HBase table. Okay, so let's see, like first let's understand how we will do that, and then we'll come back and see on the HBase shell how we'll do that. Okay, okay, so first thing is create table. So whenever it comes to the HBase, and if you want to basically insert the data in HBase. So the top level, the namespace is follow is the table, right? So you don't have the database concept in the HBase, but all it has is the table concept. So the first or the basic stuff which you will need to start storing a data inside the, inside the HBase table will be basically the create table. So how you do that create table is create. So this is the command which you will run. Okay, create. And then you give the table name, whatever the table name you have, you give the table name. And then HBase has a concept, something called guys column family. So whenever you create a table, you have to just specify the two things, the table name which you want to create, and then something called column family. So these are the only two things which you need to specify when you are creating a HBase table. What is column family? So table name is clear. You want to have the table name, whatever the table name you want to store. Okay. What is the column family? Is basically the column family is basically to group a set of columns together. Like suppose if you are having a Facebook kind of application, and if you want to store the user personal detail, user professional detail, user the social media detail, all those stuff in a separate bucket. So what you can do is you can define column family, and in one column family you store a set of the columns which are together as like a similar kind of the characteristic or the property. Like all the user details, you can have a column family called the user basic details, and you can have name, age, date of birth, all those stuff you can store that. So that's basically to group a set of the columns together, we have the concept of the column family. Okay. So whenever you create a table, what you have is you have the concept of the table name and the column family. Now next thing what you want to insert the data, because once the table is created, you want to insert the data. So how you insert the data? You have a command called put. So by using put, you insert the data inside the table. So to insert the data, you have to specify what is the table name you have. So this is the table name. So you do put and the table name. So this is the table where you have to insert the data. Then the next concept which you are going to introduce is something called the row key. So whenever you insert a data inside HBase, whenever you retrieve the data from the HBase, whenever you want to delete a data in HBase, always you have to use something called the row key. So row key is nothing but something, if you guys are coming from the structure or the RDBMS background, something you have the concept of the primary key. So similar way, in HBase, you will not be able to insert any data until it has the row key specified. So you have to specify something called the row key. And this is a very important concept because all your interaction will happen with the help of the row key itself. Okay, so you have the row key. Then you specify what is the column you want to create, right? So somebody wanted to have the column family. So you can specify the column family and then you can tell it like this way. What is the column name you have? Name. And then you specify what the value you want to store inside this. So value. Okay. So how you will insert the data? You will insert, you will use the put command. So you will tell what is the table you want to insert the data. You will specify the concept of the row key. Then the column family which you have created here. So based on this column family, you will create the column inside this. So when you are inserting the data, that time you will specify what is the column name you want to insert. And then the value which you want to store in this particular column. So in this column, what value you want to store, you will specify when you are inserting the data. Okay, are you guys with me till now? Simple stuff, creating the table, inserting that. I will show you on the command line how all this looks like. Okay, how these things happen. But first let's understand, because you want to have this mapping with your the SQL understanding, then only you will be able to basically do that on the HBase shell. Okay. Right. So now the next thing what you want to do is you want to get the data, right? So when it comes to the get the data, you have two stuff to get that. One is called scan, another one is called get. Scan is something like, it's like a kind of, I will give you like select a star kind of thing. Like if you want to see the whole table data, you can use scan to get that. So for that, what you have to do is you have to just tell scan and the table name, and you will get all the data from the table. Second stuff is get. So like suppose if you are interested in one particular row, so in that case what you do, you specify the table name and then you specify the row key which you want to retrieve. So based on the row key, that particular row, it will go ahead and fetch that. So that's the two way to get the data. One is scan the whole table. So just you tell scan in the table name, it will show you all the data. Then another way is get table name and the row key, and it will get that particular row data. Okay. So now this is the way how you get the data. So we are able to create the data, we are able to store the data, we are able to see the data. The next thing is we want to modify the data, because you guys are not always sure what you have stored. So to retrieve the data, or sorry, to modify the data, you don't have any update command or upsert command. All you have is the same put command. You use the same table name where you want to update the data. You give the row key, which row key you wanted to update, because you have, like suppose user 1, you had the name stored something like that way. Now you want to modify the name. You have to tell what is the row key, what is the the way you will identify that particular row. So you have the table name, row key, column family, whatever the column name. Suppose if this column, whatever you have inserted, same you want to update. Whatever value you want to modify, give the modified value. What it will do is, it will go ahead, find this particular row, find this particular column, and instead of this value, whatever you have, now it will have the value modified stored in place of that. Okay, so that's the way you will modify and update the record. So using the same put command, you will modify the record and update the record. Okay. Now, once you update the record, what you will want to do is next you want to delete the record. Like suppose if you want to delete a particular column, so what you have to do is you have to use something called delete. Okay, and then you have to tell the table name, which table you want to delete. So you have to specify which table you want to delete. Then you specify, like suppose if you want to delete a column, whole column value you want to delete, you can specify which row key, and then what particular column, like suppose this column family we want to delete that, so you can specify that as well. Okay, so this is the way you go ahead and delete a data. So if you want to add another column, you can use the same stuff here. So Control C, you add it here. So this is an example, guys. Suppose if you have the column name 1, now you want to have column name underscore 2. So this particular the row, it has two columns. One is column name 1 and column name 2, and then it will have the value as well. So this is the way you will add another column. So if you have the row key existing, it will go ahead and update that. If the row key is not existing, it will go ahead and create that row and it will insert the data. Okay, cool. Good. So now we did create table, we store the data, we stored another column of in that particular row, we got that row back using the scan, we got the whole table. Get, we got a selective row, then we modified the data again using the same put command which is to store the data. Then when it comes to delete the data, we use the delete, table name, row key, and whatever the column family. Okay, so this is the way how we do the basic stuff in terms of storing the data and retrieving the data and all those stuff. Okay, so now if you want to drop the table, right, what you have to do, guys, here in case of HBase is two-step process. If you want to drop a table, first thing, right, the safest thing is first step you have to do is, or the step 1 I will list it. Okay, I'm going to show you all the demo, guys, in terms of how to do that. Step 1, first disable the table. So you do something called disable, and then you tell the table name whichever you want to drop it, right? So we want to drop this table. So this exercise we will do in the last. Okay, so you disable the table and then you go ahead and tell that, okay, now since you disable the table, so no operation can be performed on this, then you go ahead and drop the table. So this is the way how you drop the table. Okay, so these are like some of the basic operation which you would like to perform on top of HBase. Okay, so with this, let's try to move to the virtual machine what we have, and then try to execute all this stuff, and let's see how things work there. Okay, okay, I will create my test table here. Okay, so let me do that then. So let me create a table called something called HTest. Okay, so this is the table name which I want to create. So call HTest. Okay, and then I want to create a column family for this table. So I will do it something called CF either. You can have any column family name. I'm just using this column family. So what I'm going to do here with this particular command, guys, is I'm going to create a table that's called HTest, and it has a column family something called CF at the column family. I'm going to hit enter. It says 0 rows, so that's fine, you can ignore that. If you do a list, you should be able to see this table. So you can see this table, HTest has been created here. Okay, so this is the way how you create the table. Create table name and the column family, hit enter, your table will be created here. Okay, the next thing what you do is you insert the data in this. So let's go ahead and insert certain record in this table called HTest. So how you insert the record, which command I have to use, guys, to insert the record? So use this put command, put, and then give the table name. So I'm going to give the table name. This is the table name I'm creating. Okay, and then give the row key. So the row key, since we are doing this on the command prompt, we will specify a particular row key. But I will show in the Java program, because most of the time you will not insert the data from the command prompt, right? This is something we are doing for the learning purpose. the actual use case will be like you will insert the data from a program itself. So there you can generate this row key automatically. Like you can have a counter and you can keep incrementing this counter whenever you insert the data. Here, since we are doing command line, I'm going to use this row key as R1 as one of the row key which I want to insert the data. Then you specify the column family which you have specified. So CF is the column family. And then in this, we will create a column called C1. C1 is the column name which we want to give that. And then specify the value which you want to add, that's called V1. What we are doing here is, as most of you answered this, put is the command which you are using. HTS is the table name. R1 is the row key, because in HBase you cannot insert the data until you specify the row key. So we are giving a row key as R1. This is the first row we have, so R1 we are giving. Then CF is the column family which we did here. Then you have the column name that we are giving here, and then we are inserting the value in this column C1, that's called V1 as the value we are inserting. Vivek says, where is the data type and size? You don't need data type and size here, Vivek. So by default, it will store as a byte array, and in HBase you don't need to specify the data type. Okay, so that's what it is, having the flexible schema. Okay, will not specify data type or columns. Yeah, Nasima, you also had the same question, so no. Okay, cool. Okay, so put htest row, column family, column name, and the value. Hit enter. It says 0 record, but it has inserted the record. Okay, so now let's go ahead and insert more value here. So now suppose you want to create another column called C2 in the same row, and then you want to have another value as something called V2. You can do that as well. Suppose you want to have one more, right, column called C3, and then the value you want to have is V3. So you can have, like, in this row you have 3 columns, C1, C2 and C3, and all these values are V1, V2 and V3. One of the things what you have, guys, in HBase is like each row can have the different number of columns. So R1 can have 3 columns, the next row R2 can have 10 columns, and again R3 can have 7 columns. So that's the kind of the flexibility you have in the number of the columns which you can store. Okay, so now the data has been inserted in this table, right? So now how to retrieve the data? So till now what we saw is store the data, we saw put, and we can store the data. So next thing is get the data. So now if you want to see the data, you can do scan and the table name, right? So once you do that, this is the way how you retrieve the data. So one is like to retrieve the whole data set. So scan, and you can see here the R1 is the row, and it has the column called C1, and then it has the value as the V1. Then you have again the same row, column as C2 and the value as V2. Then again C3 and the value is V3. So this is the way how you see the data from a table. When you are seeing the data, you see an additional column here, that's basically called the timestamp, right? So you see here all these values are the timestamp. Okay, so now let me introduce you with this particular concept of the HBase. So now when we are talking about the Hadoop, we saw that whenever you store anything inside Hadoop, by default it had the replication factor of 3, and since it had the replication of the factor of 3, so each block will be replicated to 3 different machines inside the cluster. Similar way, in case of HBase, what you have is it basically stores 3 versions of the data. What it means that is, so suppose if you have this column 1, and if you have stored the value as V1, now if you modify this value to something called V1 something, okay, or V1 dash, and then you put it something V1 double dash, right? By default, for each column it will be able to store 3 different versions of the data. Okay, 3 different versions of the data for each column it will store. So that's why it maintains that 3 different versions with the help of this timestamp. Right, so that's the concept. It has the HBase. That's what it sometimes is called the version map and reduce, because it will be able to store the 3 different versions of a particular column value inside the table. Okay. I will show you like how you can access the data in 3 different versions, right? So that's what we have this timestamp here, and this timestamp is always Unix timestamp. That's where it maintains that. Okay. Now let me do it get. Okay. So if you want, like here we had only one row, so you can specify get table name and the row, and based on that it will be able to find that particular row, all the value for that row, right? So you can use the get as well. When you're talking about this replication, guys, or the 3 versions, don't you think it like a kind of overhead, but you think of its need of the business, the business use case, right, where you want to store all these kind of the data set. Okay, so let me go back. So all the commands, you just do up arrow key on the HBase shell, you can get that. Okay, so now suppose we store this value, put htest r1 cf with the column family which we have. So basically for grouping all these c1 c2 c together, we are calling as cf, and then this value was v3. Now suppose we go ahead and modify this value. So instead of v3, we tell it something like this, v3 underscore updated. Okay, hit enter, the value has been modified. Now let's go ahead and update one more time, right? So instead of updated, you put it updated 3rd time, right? Updated underscore 3. Now if you go ahead and do a scan now, let me go ahead and do that. You will see which value we will see, guys. So we had value v3, we again put r1, and then we do v3 updated, and then v3 updated underscore 3. Now if I do a scan, what do you guys think the value is going to come in this particular row? For the column C3, what value we are going to get? Even though you have stored the 3 different versions of the data there, by default it will always show you the latest value there. What it means is, although this C3, it has the value of v3 updated, previous v3, and now v3 updated 3, it will always show you this latest value, the latest or which is value on the top. So if you do a scan, you will see this particular value here. Okay, so now the next question will come, so what happened to other 2 values? How we can retrieve that value, right? So next we will see that is, suppose if we have we know that this table has by default 3 versions of the data that is going to store. At any point, if I want to go back to a particular version, how to retrieve that particular data, right? Because you, from the table characteristic, you will know that this has 3 versions of the data. If you talk like the status message, or even like when the Google Gmail started, right, they had this concept of the status message where people used to go and put their status, and then today you put something in status, like maybe you are in Hong Kong or somewhere, you put there, right? Tomorrow again you put some other status. Then the 3rd day you again came back to somewhere and you want to update your status. So always you want to go back to the previous message and you want to retrieve that, right? So now status is 1 column and the value is 1, right? So now if you want to go back to the 3rd column, you have 2 options. Either you store all the 3 versions so user can retrieve that, or you store that value in 3 columns, you do the join, then go back and version 1, version 2 kind of thing, right? So you get the some concept. So basically all this basically to need to meet the requirement, you store all this. Okay, you got it? Okay, yeah. Okay, cool. So okay, so I think I lost the question flow here. What we wanted to see, okay, we want to see what are the different versions of the what are the different value we have for this particular column called C3. Okay, so at any point if you want to access any particular version, you can always see what all the value it has, and then based on the this particular value, the timestamp, you can always retrieve a particular value. Okay, so let me show you here. So you do get, okay, and then you tell the table name. So table name is htest, and then like the row key is the R1, the row key which we want to use, and then next I have to tell you how to retrieve a particular version. So first let's see that how many versions of the data it has, right? So you do something called column, okay, and then you specify a column family name which you have. Let me first type it and then I will explain you guys, okay. Okay. So to get any, all the, like right now we are able to only see v3 updated underscore 3. Like suppose if you want to go back and see all these stuff like v3 updated and v3. So you have to tell that, okay, for this particular, okay, so this is not C1 guys, this is C3, right, which we updated, okay. So what you have to tell that, okay, for this particular table called htest, there is a row called R1, and in that row we have a column called C3 that belong to the column family CF. I want to list all the 3 versions of this particular, the column values. Fetch that, okay. Hit enter. What you will see here is all the 3 different versions will be listed here. Only thing different you will see here is the value which you have here and the timestamp when it was inserted. So always you will see the latest one, it will come on the top. The prior to that, it will come here, and the last one is come to the bottom. Now suppose if you don't want to see all the 3, if you are interested only to see the last 2 values, you can tell 2 and you will be able to see last 2 values here, okay. What if guys, if we want to, instead of 3 we gave it like, okay, show me last 10 values. We didn't insert that. Even though we insert, it will only show the last 3 because we have set that value as 3. So if I go on updating 5 times, then first 2 versions cannot be retrieved, right? So if you do it 10 also, it will list you only, hold on, it will only list you last 3 values. Just to make sure it happens like that, let me show you, like updated 4 and then you do update 5. So 5 times we updated, okay, and then we do it 6, okay, 6 times we updated. Now if you go back and see the last 3 versions, or last even the 10 version if you want, it will always only show you the 3 things, 6, 5, 4. Rest all the 3 is gone because it can only store last 3 versions of the data. Okay, so this is the way how you list all the 3 different versions of the data. Is this clear to everybody? Cool. So let's come back, like what all we did. We did a create table, we stored the data, we get the data, we modified the data, we didn't delete the data yet, and we, okay, so a couple of other things we saw here, retrieve multiple version. Okay, now let's do one more thing. Since we are talking about the version, let me show you one more stuff. Pradeep, you want to break? Okay, give me a few more minutes, Pradeep. Let me wrap up this command line interface, and then yeah, I will come back. So now suppose if you want to retrieve this particular version, like suppose you are not interested in just listing, you particularly want to go at this particular timestamp, what was the value you want to retrieve that. So how you do that is, again, okay, you have this command called get, give the table name, give the row key, column, and then you specify what is the the column family name and the column name you have. Then instead of the version, now what you can do is you can specify something called timestamp. Like suppose you want to specify or want to get a particular version, right? So you can do time stamp, okay, and then you tell like, okay, give me this particular record set. What was the second one? Okay, so okay, so it will give you this v3 updated file. So you specify the timestamp. Based on that, it will give you this particular record. So that's the way we basically update, basically fetch a particular version of record. Okay. So now 2 things. two more things, guys, and then we will take a break. Okay, so one thing is delete the data. That's what we want to do that. And other thing is we want to modify or change the table. Okay, so let me first modify and change the table, and then we'll delete the data set. So now suppose in this table which you created, you have the table HTest, and you have a column family called CF. Now suppose you want to create another column family for this table where you want to store the data. So what you can do is you can do something called alter table, and then you can do that. So how you do that? You first disable the table, because it's a table level schema change. So always you disable the table first, so that nobody can perform any operation when you are making this table level changes. Okay. So what we want here, we want to modify this table. So first you do a disable, and then you do HTest. So you disable this table, so nobody can perform any operation on top of that. Once you disable that, then you can modify this schema of the table. You can do alter table name, and then if you want to add a basically a column family here, because column always you can add it from the command line whenever you are inserting. So you tell that something called name. So column family name, you want to add it. And then you specify what is the column. So instead of column family 1, we want to specify something called column family updated or altered. Okay, it says added. Now what you do is you enable this table. So you do enable, and then you do HTest. Okay, so the table has been enabled. Now you can go ahead and add all these, the value to this particular column family, because you have created now table. How to see that this column family got added here, guys? Always you can do is something called describe. So you can do describe HTest, and you will be able to see how many column family it supports. Okay, so it has one column family called CF, then another column from CF altered, right? So this way you can see the column family. So you have the describe command here. Disable is kind of lock unlock. So basically to perform this schema level change. Okay. So now let's go ahead and add certain value to this particular column family. So let me go ahead and get certain column here. Put command. Okay. Okay, so instead of CF column family, I can add the column family which I have added here, and then I can have the same column name there. That's not a problem, and I can have this, right? So now if you do a scan of this table, you do have the command. Yep, it will show you both. So this R1, first it has this altered C3, right? And then you have these three column family name. Okay, so that's where you make the column level schema change. Okay, so now let me show you how to delete the data, and then we will be basically seeing the dropping the table. Now suppose if you want to delete this particular row or column value, you can always use delete. Okay, so you do delete, and then you specify the table name which you want to delete. So the value from where table you want to delete, that's HTest. Okay, and then you specify the row. So in our case we have only one row key, so we'll use R1 here. Okay, and then you specify what value you want to delete. So like suppose if you want to delete all these values related to the column family C1. Okay, so you can tell that I don't want to see in, let me delete this C3, okay, because it has both place. Okay, C3. So what we are telling that, go ahead and delete from the table called HTest, the row ID is R1, and in that for column family CF, whatever the value we have stored for the column name C3, go ahead and delete that. Okay, it says deleted. Let me do a scan. You will see that this particular column which was listed here earlier, it's got deleted now. So that's the way you delete the data from the table. Now once we are done with all this, so creating the table, storing, getting the value, modify, seeing the different version of the data, deleting the data, the last stuff to drop the table. Okay, so now let's see how to drop the table. So let's go ahead and do that. So first what we have to do, let's come back to the command which you listed here. So first disable the table and then drop the table. Go ahead and do disable. Give the table name htest. Table has been disabled. Now go ahead and drop the table. Done. Now if you go and do anything like this, list, hold on, first let me show you. You do a list, it will not show you this table because table is not there. If you do a scan or something, it will throw you error. Okay, some example. Okay, so this is the way how you, drop the table. Okay. Okay, and then we'll see some more stuff related to HBase. Okay, Control Enter. Okay, so let me show you a bit. I think this will be a better basically kind of interface for you to understand all this stuff. So just now we discussed a couple of concepts that's basically about the table, row key, column family, and all that. So basically you can understand in this way, right? So suppose if you have a table, basically the user table, if you want to create, right? So your employee ID or whatever the employee 1, 2, whatever you have, that can act as a row key which you have. Then the different kind of the details which you will capture for the employee, right? Maybe the personal detail, the address related detail, right? So you can create a column family that will be like the personal, and it will create the details like name, age, password. You can have another column family that will have the address, and it can have the street, city, state. So that's basically the column family which you create. Inside each column family, what you have is you have the column name. So you can have the name, age, password. So these are the column name it has. Then for all these column name, you will have the values. So you have the name, you have the age, you have the password. Now each of these values which you store, it has a timestamp associated with this. And why you need timestamp? Because in the HBase, all the data will be stored in the multiple versions. So in this case, password, you have the multiple password like password 1, password 2. So there are 2 different versions stored here. Similar way, for the address, you can have the street, but you may not have the any value associated with that. But the city, it can have the some number value. State, it can have something, right? So that's the way how the the table, row key, column family, column name, and basically that's called the column qualifier, and then the different version of the data and the value it is stored. Okay. Okay, so let's come back to the slide. So similar way, guys, here on the slide as well, you will now if you understood what all we discussed till now, right? So you will be able to understand this stuff as well. So here what you have is you have the different row key and the associated value with that. So whenever you will store any data here, so you can have this all these XYZ, AAB, right? 1, AA, all these are basically the row key, and you have the value associated with that. So all this data will be basically the sorted. So whenever it comes to the HBase, it will always sort the data, and then only you will have basically the data getting stored inside that. So it will also follow this key value store where like one is the row key which you have, and then you have the column family. So A is one column family, B is another column family for a given row ID. And then for this column family A and B, you have the 2 column names called X and Z. That's the column name which you have. Similar way, other the row key, they have their own the column family and the column name associated with that. And all of these can have the variable schema, guys. So that's one thing. One row can have 3 columns, other row can have 9 columns. So that's the flexibility we have. only the row key is sorted, or the data? No, the data will be sorted based on the row key, Chandra. Okay. So so suppose if you have this particular structure, so you have row key as AAA, and then it has A as the column family, and then you have two different column names, that's basically foo and the bar. So they are the two column family, and then they have the value associated with this, right? So that's the way it is stored. So again, you have this A as the row key, and there is the column qualifier which you have, and then these are the column name you have, and then the column value associated with that. Now, since all these column value, you can have the timestamp. So like this is the row key, this is the column family, these are the column, foo is the one column, and then you can have multiple value, like at this particular instant, this was the value, another instant, this is so these are the timestamp value which you have. So 15 and 40 are example of timestamp, and YM are the values of that, but like how we had the V3 updated and V3 updated 3, right? So that's the value what you have for Y and M. So whenever you want to access any particular column in HBase, guys, what you have to do is you have to specify the table name, then you have to specify the row key, then you specify the column family, then the column name, and then the timestamp. If you don't specify, by default the latest one, then you get the value. So that's basically the flow what you have to get a value from the HBase table. Table name, row key, column family, column name, and then the timestamp, and then you get the value. So that's the way how you identify, or how you basically reach to a particular cell in a HBase table. Okay. So these are like the storage. So when we talked about the difference between RDBMS and the HBase, we talked that HBase stores the value in the column-oriented storage, while the normal RDBMS row storage. So that's what the difference, you can see it here. So when it comes to like storage in the HBase, like suppose if you have a table like this way where you are capturing the URL ID, URL, the short ID for that, title, description, and the content. Now, if you want to store this particular row in HBase, so how it will be stored is basically all these, one particular column will be stored together. So all these URL, they will come as a single row here, and that will be stored together as a single row. So that's the way the column-oriented storage is. Similar way, short ID, all the value of this short ID, it will come as a single row, and that will be stored inside the HBase storage. So that's the way how HBase will store the data internally in terms of the storage. So it will be storing on the column oriented instead of the row oriented which we have in the normal RDBMS table. Okay, and the reason why we have this kind of a storage is because whenever you perform any kind of operation on these tables, especially the tables which is stored in RDBMS, you basically need all these column values together. Like suppose if you want to filter, how many people are from the a particular title, like a sport news they follow, or any particular description, you will always need to basically read through all the records for that particular column. So that's what this particular storage works very well in terms of those kind of access requirement. Okay, so when it comes to the the storage, right? So always the data whatever you store inside HBase, it will be basically sorted data, and the sorted will be based on the row key. So in the table you have R1, R2, 3, so it will be always sorted, and you will be stored data together, and that's again the column oriented storage which you will follow. So a table in HBase, it can consist any number of the columns. So that's the one of the flexibility you have with the HBase. So there is no limitation as such with the number of the column. There are some certain limitation with the column family, but there is no a limitation in terms of number of the columns. It can consist of any number of the versions. So you can have 3 versions, 5 versions, depending on your requirement you can store. Only thing what you have to associate is that if you go for more versions, it will have more overhead associated in terms of maintaining all those versions. And the columns, when you when you insert the data at that particular time, you can specify the column. So as we saw in our discussion here, guys, so whenever we were inserting the column, we were specifying the column name, and based on that, the value was getting inserted. So that's the kind of the flexibility hub. So columns in a family are sorted, family are sorted and stored together. So all the column in a column family will be stored together, and they will be sorted. So these are certain characteristic of the HBase in terms of the storage. Now, one thing is, since it has the flexible schema, guys, so what you will see in the HBase is like it doesn't need you to specify everything. Like suppose if you want to have, one row with 3 columns, another row with just 2 columns, it will just take it. It doesn't specify or, doesn't, constrain you to have specify all the column names. So those kind of the flexibility you have with the HBase. So you can see here, like suppose if you have this particular data model where you are storing the data in two column family called personal data and demographic, and you have the columns like personal name and address, then demographics you have birthday and gender. Then for different user, you can have different kind of the storage. Like for this particular user, we don't have the address part, so you can leave it blank. HBase is not going to basically complain that. For the 4th user, you don't have name, address, and birth date, but only have the gender, so you can just store that as well. So that's the kind of even sometimes you can omit the column name as well, and you can store the data. Okay, so in terms of the storage, as you can see here, so all these column family, they will be grouped together, and all the columns it will store. So like personal data, it will have all this like address, name. It will be stored together in one column family. Then other column family, demographics, it will have gender, birth date, it will be stored together. Now when it comes to storage of this one, right, so multiple row, it can have different, like row 1, it can have the data in both the column family. So here we have like it has the address, it has the name, and as well as it has the gender and the birth date. That's what we have for the row 1. So that's what it will be spanned across both the column family. So if you go back here, you can see here it has the name, address, birth date, and the gender. So that's what it is stored across the 2 column families. Right. So how the data looks like now, since we already saw the HBase from the command line. So generally, if you are just going through the slide, so this is the way how the data looks. So you have the row ID, row 1, row 2, and then you have the column family name. So data is the column family name, then the column name you have, and then you have the timestamp, and then the value associated with that. So you can see here the row ID, column family name, then the column name which you have here, all 1, 2, 3, the column, then this is the timestamp value, and then the actual value associated with that. So this is the value which you have. So that's the way how HBase table looks like internally. When it comes to the row key, it's basically unique for each row. So each row will have the unique row ID, and that basically helps you to identify each row. And the less number of the column family gives the faster access. The reason for that is, guys, basically if you understand the internal storage, how it works. So HBase has a concept of something called the mem store. So whenever you store, as I told, HBase is basically having the in-memory implementation. So whenever you store anything in HBase, first it will be stored in memory, then only it will move to the disk. So basically for each column family there will be a mem store that will get created, an H file. So that's what you have the less. So restriction is you should have like 5 to 10 kind of the column family, but in those 5 to 10 column family you can have any number of the columns. So whenever you define a table, you are basically define the column family. So that's basically the fix, but the number of the columns that you can have in that, it is basically flexible. So you can have any number of the column inside that. And if you want to add the column family, as we saw, alter the table, you disable it, alter, and you can add the column family as well. In terms of the value, you can store the different versions of the value inside the table, and when you do the scan, it will only show you the latest or the recent version of the data. Okay. Once again, row key, it's going to be unique for each row. Column qualifier, it is basically the general guideline is not to have a large number of the column family, but you can have any number of the column inside the column family. Values, always you will see the recent value that you will see on the top, but it can have multiple versions of the value that can be stored inside the HBase table. Is it clear, guys? Are you guys with me? Because next we are going to see the architecture, how it does the storage. Yep. Okay. Cool. So when it comes to the HBase storage architecture, guys, so it's again follow this master and the slave architecture, how you have in case of Hadoop, right? So Hadoop HDFS, how it has the concept of the admin node and the data node, where you have the admin node does the monitoring of the whole storage process and the execution, and the data node is where the actual storage and the execution happens. So similar way in case of HBase as well, it has this master and the slave kind of the architecture, where you have H master that basically the H master basically controls the whole the HBase cluster, and then you have the HBase region server that stores the actual data and retrieve that, and you have the HBase client. By using that, you interact with the HBase. So when it comes to the storage inside the HBase, so you're like how in case of normal Hadoop HDFS storage, your data will be distributed across multiple machines in terms of the block. So similar way in case of the HBase, like suppose if you have 1,000 record or 10,000 record, so your data will be also distributed across multiple machines, and that's where all this horizontal scalability comes in picture. So you have the multiple region server that basically actually store the data. So like you can have a starting till A3, it is stored in one region server. So next set of the records in another one, the another set of records in the next another region server. So that's where your data will be distributed across multiple machines, so that it can give you the performance as well as the storage when it comes to store the large volume of the data. Okay. Okay. So now the next thing what we are going to understand is about the HBase read and write. I think some of you had this question like how the read write happens, right? So now let me pull the slide here. So this is like additional stuff, guys, which you will basically help you to understand how the HBase read and write happens. So whenever you try to store anything inside the HBase, HBase has something called the in-memory implementation, and that's what you see the very fast kind of the response in terms of the HBase when it comes to storage as well as the retrieval. So whenever you store anything inside the HBase, what happens is it will be stored in the memory, and inside the memory what we have is something called memstore. So for each table you will have something called the memstore that will get created in memory. So whenever, like suppose if you are doing a put operation, the first operation, the storage, it will happen in the memory or in the RAM, and that will be basically in the memstore. Now you do the next put, it will again get added in the memstore. So this memstore is a limited size that is there in the memory because it will be shared across multiple HBase table. So by default, like suppose if you have 64 MB in the memstore size, so at one point it will get occupied. Like suppose if you have inserted maybe 1,000 record, the memstore will be completely filled. So at that point, what HBase does is it will basically move this content, whatever you have in the memstore, to the disk. And how it moves the data to the disk, it will use basically the concept of H file. So it will create a file that will be basically called the H file, and this H file will be moved and stored inside the storage what you have inside the Hadoop. So every time whenever the memstore is filled, it will create a new H file, and that it will be stored on the inside the Hadoop file system. Now, when it comes to writing to HBase, we have that the write happens in the memory. That's what you get the faster performance. But since the write will happen in memory, if the machine goes down, you will basically lose all the information. So to avoid such kind of scenario, what we have in HBase is something called the write ahead log. So whenever you are writing anything inside HBase, it basically goes to the two places. One is in the mem store, that is memory implementation. The other one is something called the write ahead log, that is basically on the disk. So in case if you have a failure or you restart the server or some kind of issue with your machine, you can always retrieve that information from something called the write ahead log. Right. So that's the way how the the write operation or the storage happens inside HBase. So basically the mem store, it will store the first the data, and whenever it gets filled, it will create a new H file, and that H file will be basically moved to the Hadoop file system. So that was in terms of how you perform the write operation. HBase storage happens in HDFS only, right? Yes. So underlying if you want to persist the data in HBase, it will go inside the HDFS file system. Okay. So now when it comes to the retrieval of the data, again it will try to, like, suppose if you have inserted a record and that record is already available in the mem store, so it will try to get you that record from the mem store itself, right? So that's the way how it will retrieve the data. If the data is not available here, what HBase has the concept of something called the block cache. So it will maintain the recently used data in something where in the block cache. So in case the data is not in mem store, it will try to get the data from the block cache. In case if the data is not available either in these two memory stuff like mem store and the block cache, so in that case it will go ahead and fetch the data from the disk, and that's basically from the H file, and then it will serve to the client. So that's the way how HBase retrieves the data from the storage. Okay. So this is the way how the data get moved. So you have the mem store. Every time the mem store get filled, you create the H file. So down the line, what happens? You have the multiple H file that gets created, and that's where the HBase runs something called the compaction process. So during the compaction, what it does is these small files, it will basically open it up and group it as a bigger H file kind of thing, and that it will be stored internally. So that's where I think somebody had the question about the delete. So whenever you delete anything in HBase, basically that delete will not happen immediately, because all these H file you see, it is basically called the Java immutable object. So what it means that is, if you have stored these data in terms of the H file, you cannot go and change that particular H file. So next time, suppose if you delete any data or update the record, it will be maintained in some other H file, and only thing is it will have the latest timestamp, so you will be able to retrieve the data. It will be during the compaction process, that's where this Java immutable objects will be basically open to write, and that's where you will go ahead and delete the old data which is flagged as basically deleted and the modify, and you will basically have the latest value that will be stored finally on the persistent storage. Right. And then we saw already this detail, like how you store the data here. So now let's come back to the slide. So the HBase component, you have the master node, HBase master, that basically control the whole execution, and then you have these region server where you get this mem store created and where the actual data will be stored. So whenever this mem store is filled, you will move the data to the Hadoop file system in terms of H file. And since you are always storing the data in memory, so to have a backup of that, what you have is something called the WL. That's nothing but a write ahead log, which we saw here. So whenever you store the data, it goes in memory as well as it goes in the disk as well. Right. So when it comes to the HBase components, so HBase basically is having the table, and table is made of the different region. So it distributed across multiple machine, and each machine stores a different region of the data, like 1/3 of the data on one region, next 1/3 in another region. So like that way it stores the data. And a region is nothing but a range of the rows that are stored together. It's called the region. And region servers serves basically one or more regions. So a region is served only one region server. So like 1/3 of the data, it will be stored on one particular region, but that region server can have the multiple region for the multiple tables as well as for the same table. And master server, which we have called the HMaster, it is basically again like a Hadoop architecture. It will be basically maintaining this whole Hadoop cluster. And then you have the storage of the HBase. Again, it happens in the HDFS, so that's where you get this high availability as well as this fault tolerance from the Hadoop file system. Okay. So since HBase is a kind of a distributed application, you have multiple machine involved, and you need basically synchronization across multiple machines. So you have the Zookeeper as one of the application that helps you to synchronize all these processes, basically locking, sharing the resources. All those synchronization activity or the coordination activity is done with the help of the Zookeeper. So as you can see here, the underlying architecture of the HBase is Hadoop file system. So that's what you have, the HDFS. Although the diagram looks complicated, guys, but nothing is there in this particular diagram. This is the HDFS where you have the data node where the actual data will be stored. Now, when it comes to the HBase, you will always write the data in something called the mem store. So that's what you see the different mem store here. And each mem store will move this data to the HDFS in terms of the H file. So that's what you see all this diagram here coming to the H file. And DFS client is nothing but a distributed file system client. So it will move this H file to the data node as the storage. So that's what the storage you have. And all these activity will be controlled by the H master. Right. So to maintain this whole stuff, what you have, guys, all these stuff remains same as in the Hadoop cluster. So you have basically the name node. You need this name node to store any kind of the file inside this. Then you have the secondary name node concept. Then for the HBase, you need HBase master. So all these are basically the management node or the admin machine which controls the whole execution of the HBase cluster. Then you have the data node. That's again the commodity hardware where the actual storage happen, and where you have this HBase region server that will be running on each machine in terms of the storage. Okay. So now when it comes to the HBase, as like this all H files, it's a kind of the immutable object. So whenever you are writing a record, the files will be written inside the H file, and over a time you will accumulate a large number of the H file inside the storage. So what it does is it runs basically a compaction. So during the compaction, it will basically group all files together, and when it is doing the compaction and that particular stuff, these objects become writable. So that's where you go ahead and delete a particular record or the particular version at this particular time when you are doing the compaction process. So generally in your HBase cluster, this compaction will be scheduled based on your cluster configuration, or your admin team will run this compaction, and based on that, this the merging of this small H file will be done inside the cluster. Okay. So now what we will see, guys, is we saw all these HBase shell command, guys. So we did create. So you create a table here, you do a put, and you update the record. So all these commands which we saw, if you do a scan, you get all these records here. Right. So now the next what we are going to look is the different HBase clients. So right now we saw with the HBase shell command. Next we'll see from the Java program, if you have to interact with the HBase, how you do that, right? So that's what we are going to look here from the Java program, how to interact with the HBase and use all these, the HBase API to call from a Java program. Okay. Cool. So with this, we are good to wrap up the class. Guys, please provide your feedback. Okay. And then see you guys next week. Bye.